All right, good day and welcome back to Everything Mathematics. And today we're going to continue our series on matrices. And today we're specifically going to be looking at how to find the inverse of a matrix, which is basically a culmination of what we would have started 2 days, or you could say 3 days ago, since last week, Friday, where we first looked at the adjoint, then we looked at the determinant yesterday, and today we're going to make a marriage. We're going to put both of them together. So let's start with several examples. I think this is the best way to go about doing this. So let's say we have matrix R, say R and I write in B. So let's say we have matrix R is equal to -8, 5, 3, and -4. The whole essence of finding the inverse of a matrix, in other words, we're finding the inverse is represented by R to the -1. This is simply saying that we'll have 1 over the determinant of R, whatever that is, and then we're multiplying that by the adjoint of R. So this is really and truly the concept of the determinant. So in essence, we're finding what is the determinant of R, we put it under 1, and then we multiply that by the adjoint of R. And it might look complicated, but let's do a few examples and then we'll see how easy it is. So we do need the determinant and we also need the adjoint. So whichever one you choose to find first, that's up to you. I'll start with the determinant first. So I will find what is R, the determinant of R. And remember, that's the product of the leading diagonal minus the product of the minor diagonal. So in essence, that will be -8 multiplied by -4. And then we're subtracting that from 5 multiplied by 3. When we solve this, of course, we'll get 32 minus 15. And 32 minus 15, if my math serves me well, that's supposed to be 17. So this is the determinant of matrix R. Then we also need the adjoint. We need the adjoint of matrix R. So let me see if I could just do the adjoint across here. So the adjoint, in case you forget how to find the adjoint, remember the adjoint is simply we switch the positions of the leading diagonal and we switch the signs of the minor diagonal. So if you look at the matrix of there, you will see that 8 and -4 are the leading diagonal. So if I want to find the adjoint, those two numbers will switch positions. So I have -4 here where the -8 was, and then I have -8 here where the -4 was. And in the minor diagonal, the signs change. So since both are positive, then both will become negative. And guess what? This is all we need for the determinant. For the inverse. All we need to do here now is put them together. So again, I'll just write back what I had earlier. So remember, R inverse is the same as 1 over the determinant of R, and we're multiplying that by the adjoint of R. And guess what? We have everything here. So R inverse is equal to 1 over 17, which is the determinant, and we multiply that by the adjoint, which is in this case -4, -5, -3, and -8. Story done. That's it. What some teachers do, and I guess I think that's based on who's teaching you, based on your professor, teacher, whoever, it doesn't matter. Some teachers will accept it just like this. For some teachers, this is perfectly acceptable as an inverse. For some others, they prefer to see it multiplied. So they prefer you see the determinant as a scalar, and then you multiply that by the matrix. And if I do that in this case here, then I will simply have a final answer of -4 over 17. Hope you see where I'm coming from. Then you have -3 over 17. In other words, I treat the determinant, or sorry, not the determinant, I treat what is outside as a scalar, the 1 over 17. And then I have -8 over 17. And this will be my final answer. Let's say some teachers prefer to see it like that. Good. So this is basically the thought process through it. We have matrix R. With that, of course, you find the determinant, then you find the adjoint. And once you find those two things, you just put it together. 1 over the determinant, and we multiply that by the adjoint of R, and that's it. As I said, based on the teacher, it will be acceptable like this, or sometimes you just have to multiply it out. If you have to prove that R, the inverse of R times R will give you the identity, then of course you'll have to multiply it out. But if not, if you just ask for the inverse, then this will be perfectly acceptable. Granted, of course, that your determinant is correct and your adjoint is correct. Let's do another one. Let's just do another one for practice. So here we have matrix Q is equal to, they have it here as -7, -4, 3, and 2. This is matrix Q. And we are asked to find Q inverse. In other words, they want us to find the inverse of matrix Q. So what do I need for that? To find that inverse, first of all, I need the determinant and I need the adjoint. So let's get the adjoint first. It doesn't matter which one you do first. So the adjoint in this case would be 2, -7, and this 4 now will be positive and the 3 will be negative. Remember, change of sign this way, change of position this way, right? And then we do the determinant of Q. The determinant of Q in this case now will be equal to what? The leading diagonal, so that's -7, the product of the leading diagonal, -7 times 2, and we take that away from the product of the minor diagonal, which in this case is -4 times 3. When we solve that now, we end up with -14 here, and then we have that minus, oh, look at this here, -12. 4 times 3 is 12, and the negative and positive is negative. But you see this negative and this negative will make a positive. So in essence, we will have plus 12. Good. And then, of course, when we operate this, when we compute this, we will end up with -2 as our answer. And with that, we have everything we need. So Q inverse will be equal to, remember, 1 over the determinant, which in this case is -2. And we multiply that by the adjoint, which is 2, 4, -3, -7. And there you go, another example. And that's how we get the inverse of matrix Q. That's the whole works there. Let's try one last one, and we should call it a wrap for today. So then we have matrix L. So let's say matrix L was given as -9, -4, -6, and -5. Oh, those are some big numbers. So that's matrix L. And again, we were asked to find what is L inverse. And remember that negative sign there is an inverse sign and not L to the -1. Although based on how we look at it, it could be that too. But yes, in this case, yes, that's the symbol or the sign we use to represent inverse. So again, this time I'll find the determinant first, and it doesn't matter which one you want to find first. Again, it's the same thing. And notice here I'm using a different connotation, a different notation. For the first two, I use the modulus sign. Here I'm just using det of L. That's equal to the product of the leading diagonal minus the product of the minor diagonal. So that's this here. 9 times 5, that's 45. Negative and negative will make it positive. And we're subtracting that from 9 times 3, which is 24. And again, the negative and the negative here will make it positive. So that's 24. And that's equal to, oh, and then we compute here, 45 minus 24, that is what? 4 take away 5 is 1, 2 take away the that, so it's 21. So that's 21, positive 21. 45 minus 24 is 21. And of course, if I add back these two numbers, I will get back my 45. So that's for that. And let's look at the adjoint. Let me just slide across a little. Right. And for the adjoint now, adjoint of L, the adjoint of L will be equal to switch position, switch signs. So that's -5, -9, and then +4 and +6. That's my adjoint. And this is all I need for the inverse. So then my L inverse will be actually equal to 1 over 21. and I multiply that by the adjoint, which is minus 5, 4, 6, minus 9. Easy does it. And of course, if you want, you could multiply your scalar here by each element inside of this matrix, if you so desire. And that should give you, again, the same thing, is just distributed. But I wouldn't play too much with that. I will do that when we're looking at what will happen when we multiply the matrix by the inverse. So yes, we're going to wrap it up for today. And again, this is a very simple concept. Just keep practicing. Tomorrow, God willing, what I'm going to do, I'm going to show you how we will get the identity, or how is it that we're supposed to get the identity at all times once we multiply the matrix itself by the modulus. Not the modulus, now the matrix itself by its inverse. So in other words, I will show you that if you have matrix L and you multiply that by L inverse, you will end up getting I. I is the identity matrix. And in case you forgot what the identity matrix look like, the identity matrix is 1, 0, 0, 1. So whenever you multiply a matrix by its inverse, you will always get the identity. And that makes a lot of sense. But we're going to discuss that a little more tomorrow, God's willing. So until then, you take care. As always, feel free to like, share, subscribe. And if you haven't, especially if you haven't as yet, yes, please do subscribe. Until the next time, you take care.